Welcome back to another explainer. Look, if you've ever dug into programming or data management, you've probably bumped into SQL and thought, great, just another bunch of syntax I've got to memorize. But today, we're going to totally flip that script. We're diving deep into exactly why databases had to be invented in the first place and how they literally saved the modern digital world from absolute chaos. Once you get this, all that complex syntax won't just be rote memorization, it's going to feel completely 100% logical. So, here is our roadmap for today. We're going to start with the world before databases, then we'll look at the problem with files, enter the DBMS, talk about speaking to the database, and finally check out the engine under the hood. Let's get right to it. Section 1, the world before databases. We are traveling all the way back to the 1960s era to see how companies actually functioned before the tech we take for granted today. Okay, picture this. You've got a small company back then, maybe just 10 employees. Keeping tabs on their names, their departments, and what they get paid in a basic text file? That worked perfectly fine. It was simple, you could read it easily, and honestly, when you're only dealing with a handful of records, you just don't need a massive, complex system. It was perfect harmony. Back then, early data storage was literally just basic text or spreadsheet files. You'd open it up, type in Employee 101, Rahul, sales, 45 grand, and you hit save. Done. And for a long time, this was completely sufficient. It was just how business was done. But as these businesses started to grow, a massive crack in the whole setup started to show. Now I want you to imagine trying to scale that manual process up to today's standards. Think about a giant like Amazon. Instead of 10 employees, you're looking at roughly 1.5 million employees, 500 million customers, billions of orders, and literally trillions of individual data records. Can you imagine trying to open one massive Excel spreadsheet with trillions of rows? Your machine would just instantly freeze. It's a complete non-starter. And that kind of massive scale leads us straight into a complete catastrophe, which brings us to Section 2, the problem with files and their catastrophic flaws. Let's look at one of the biggest flaws. Data inconsistency. Say we have a student named Arjit, and he's taking classes across 3 different departments. If the school stores everything in separate text files, Arjit's info gets copied over and over. Now, what happens if Arjit gets a new phone number? Department A updates their file, Department B completely forgets to do it, and Department C types it in wrong. All of a sudden, you've got 3 completely different phone numbers for the exact same guy. So which one's right? Honestly, nobody knows. That kind of data redundancy is an absolute nightmare for a business. First off, it wastes precious digital storage space by just endlessly duplicating the same data. It makes system upkeep basically impossible, and it creates this severe inconsistency where, just like with Arjit, nobody actually knows which record is the real truth. And on top of that, you've got this massive problem with relationships between data. Let's say you have separate text files for your employees and totally different files for their salaries. How do you actually know which salary belongs to which person? Well, in the old file system, you were forced to manually match IDs line by agonizing line because simple text files have absolutely zero built-in relationships. The computer doesn't magically understand that an ID in file A connects to an ID in file B. Then you add in the sheer chaos of multiple users. Imagine 500 people trying to edit that exact same spreadsheet at the exact same time. It's wild. People are constantly overwriting each other's changes, conflicting edits are popping up everywhere, and accidental deletions are a daily reality. Plus, there is zero fine-grained security. Anyone who can open the file can just casually view confidential salaries, or worse, delete the entire thing. And the most terrifying part? It's a single point of failure. If the one laptop holding that master Excel file crashes without a backup, it's a total loss. It is a literal recipe for business failure. But perhaps the most critical flaw of all is how this handles interruptions. Picture a bank transfer. You're moving $1,000 from account A to account B. Step 1 finishes, so the money leaves account A. But suddenly, boom, a power outage hits before step 2 can even start. Without a system that guarantees complete transactions, that money doesn't just magically bounce back into your account. It just vanishes into thin air. So you can see why computer scientists realized these catastrophic flaws had to go. They needed to invent a hero to save the day. Which brings us to Section 3. Enter the DBMS, the Smart Manager. They engineered a piece of software specifically for managing all this data efficiently, and they called it a Database Management System, or DBMS for short.
Think of this software as a highly intelligent manager that sits securely right between us, the human users, and the actual raw stored data. It single-handedly solves the redundancy issues, locks down the security, and guarantees that things like bank transfers either happen completely or they don't happen at all.
Let's clarify two terms that people mix up constantly: the database itself versus the DBMS. Think of it like a giant library. The database is really just the passive collection of information. It's the physical library building and all those stored books just sitting quietly on the shelves. The DBMS, though, that's the active librarian. It's the software actively controlling who gets in, updating the checkout records, securing the building, and helping you track down exactly the book you need so you aren't stuck wandering endless aisles by yourself. And this setup is literally how our entire modern world operates. Whenever you book a train ticket online or just check your bank balance on your phone, the application you're tapping on doesn't actually touch the raw data files. No way. Instead, your app politely asks the DBMS librarian to handle the whole transaction. The DBMS checks if that train seat is open, securely updates the database, and gives you your confirmation. So let's take the next logical step and see how this all connects to our daily data interactions in Section 4, speaking to the database with structured queries. Okay, if the DBMS is our active librarian, we obviously need a common language to talk to it, right? Because you can't just speak casual English to a computer program and expect it to understand. And that is exactly where SQL comes in. Structured query language is this specific, standardized language that both humans and applications use to communicate requests, update records, and pull information super efficiently from the DBMS. What's so brilliant about SQL is its sheer elegance. With just a really basic command, something like select name from employees where employee ID equals 101, that exact instruction gets passed straight to the DBMS. The DBMS understands the SQL perfectly, dives into the massive database, grabs precisely what you asked for without searching row by row, and hands it right back to you. This creates the incredibly secure flow of data that powers basically every single app you use today. It always goes like this. You write the SQL query, the DBMS securely processes it, the database allows the retrieval, and the exact result is handed back to you safely. We're talking no file corruption, no vanished money, and no accidentally overwritten data. It's brilliant. Now that you deeply understand the massive problems databases solve and the flow of how we actually interact with them using SQL, it's time to look a little deeper in Section 5, the engine under the hood. Think of everything we've talked about today as just opening the hood of a car. You now know exactly why we needed the engine, and you know how to use the steering wheel and the gas pedal. But that leaves us with one incredibly powerful question for our next explainer. When you hit the gas, when you hit execute on that SQL query, what exactly is happening deep inside that DBMS engine to make it all work so flawlessly? Think on that for a bit, and I'll see you in the next one, where we are going to tear that engine down to its absolute core.